Hi and welcome everyone. Today we're going to look at how you can utilize external services to make it easier and faster to develop Android applications. More specifically, we're going to look at some of Google's own services that are going to make it easier for us to create a backend for our application. To start out, we're going to have a quick recap of what you learned last time about networking, about consuming a RESTful web service. Then we're going to get an overview of the various services that Google offers for our Android applications. And then we're going to dive into two specific services. The first one being Firebase Authentication that makes it easier for us to make a sign-in flow for our application. And then we're going to look at Firebase Real-Time Database, which is going to make it easier for us to create a cloud database that can synchronize the data in real time. And of course, in the end, there is a lot of exercises for you to work with as well. Okay, so let's get started. What did you learn last session? Well, we talked about networking, more specifically how we could consume a RESTful web service, and for that we basically used this library called Retrofit, right? And this was basically the last missing puzzle in our architecture right here, where we learned that our repository could actually receive some remote data by using this Retrofit library that could fetch some data from a web service. And this data here that was fetched was basically JSON data, and we learned how we could deserialize that data into Java objects using the JSON library from Google as well. And yeah, then basically we also talked a bit about the various kinds of web APIs in terms of their restrictions and what you could access. Some of them requiring API keys, some of them requiring OAuth and whatnot. And you saw how you could basically implement that. And then also briefly we talked about the image loading library such as Glide you could use for actually displaying data, since displaying images, since that's not something that Retrofit offers itself. Yes, but that's basically like on a very high level what we talked about last time. Now let's get into today's topic. So that is Google services, or just services in general that you can use to make your app development faster. And since Google are the authors of Android, they've also offered a few services for you as well that you can use. Most of them are in what is called Firebase, and then some of them are still left in what's called Google Play services. But they basically have these two different places where they put their services. And since they bought Firebase, they started to migrating most of them to Firebase. But it's services such as analytics and cloud messaging, authentication, all the things you can see over here. And I'm just going to gloss through some of them right now, and then we're going to go in depth with the authentication and with the real-time database afterwards. So, Firebase. What is Firebase? Well, it's basically a service that allows to act as a backend for your application. So instead of you having to go in and write your own backend, then you can just use Firebase, which is basically just a web console where you can set up your backend in terms of authentication and in terms of the real-time database, which we're going to look at today, and in terms of a lot of other things, as you can see right here, and things they offer. The cool thing about this is they have a very generous free tier, and it's basically developed for mobile applications. So under the hood, it's Google's cloud platform that works, but it's basically tailored for mobile applications. So that's the market they're going for here. I guess we can just watch this small introduction video so you get a better idea of what's going on.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more.
Yes. So you can see basically if you have some customers and you want to develop an app for them, then it's often much cleaner to create a backend in Firebase than having to set up everything yourself and host it. So that's often what I would recommend. It's fast and easy, and most of the time you can get away with just using the free tier for your customers. That's very nice. Let's just dive through some of the features that are available in Firebase and in Google services in general. So first and foremost, you can actually authenticate your users, so you can have a sign-in flow in your applications using Firebase. I've seen some students already trying to do sign-in on their own, but this year that's actually much better in a few ways. So one of them being that you can actually have third-party providers for sign-in. So you don't have to sign in with your own email and password. You can also use Google Sign-in, Facebook Sign-in, or GitHub, or whatever other sign-in services are available. Most of them are already in Firebase. And they will also leverage ready-made user interfaces for you. So all of the sign-in flow with creating new accounts and these kind of things are also already available to you. And actually it's not only for Android development with the official Android framework in Java. You can also use this for iOS development, or for even for Unity or some web-based stuff. So it's available in a lot of different frameworks. Okay, then we have the Firebase real-time database, which is basically just a cloud database that is no SQL, so it's not a relational database. This one, they have a few options, document-based databases, and the cool thing about this is that it's real time. So that means whenever you update the database in the cloud, it will notify any connected client and tell about the update immediately within milliseconds. So that we're going to look at today. Then there is Firebase Cloud Storage, which is basically just a place where you can store large files, images, audio, video, and so forth. I'm not going to show the video right here, but you can click it if you want to know more about it. But it's basically a good way to store these kind of data files as well. Then we have Firebase Cloud Messaging, which is actually quite essential if you have your own backend. So imagine you have your own backend and you want to notify your client, you want to notify your Android applications that some data was updated in the backend. Then you can push that data directly to the Android devices, and actually without even having your Android phones open. So this is very powerful, so you don't have to go in and create all of the polling yourself, which might take up a lot of battery and these kind of things. So Google has basically optimized this for you and created some way where you can actually push data to your Android devices. And you can see it's basically just some admin SDK you have to use in your own backend, and they support various languages, like you can do it in C# and Java and everything here already. But let's just watch this video so you get a bit better impression of what I'm talking about and why it might be useful to you. Oops.
Firebase makes sending messages to your users easy with Firebase Cloud Messaging. It's a free service that allows you to send messages to your users' apps across a variety of platforms. Messages can be addressed to single devices, groups of devices, or even topics. Building a notifications or messaging system with Firebase Cloud Messaging is easy. First, you register your user's app instance with the Firebase Cloud Messaging servers. Then, on your server, you write code that allows you to address these devices by ID, group, or topic, and which tells the Firebase Cloud Messaging server to send the messages for you. It's powerful, it's scalable, delivering hundreds of billions of messages per day, with 95% of messages being delivered within 250 milliseconds to connected devices across many different platforms. It's that easy, it's that powerful. Firebase Cloud Messaging.
Yes. So you can see that's a very powerful thing, for instance, for the 4th semester project with some of you are doing. If you want to notify some of the clients about some updated data, then you can do it this way instead of setting up a timer or whatever in your Android application. Yes. Another thing that's interesting is Firebase Cloud Functions. So I guess you've seen the trend going from platform as a service and moving on to software as a service. Then it's basically just not having a server anymore, but you're just calling functions in the cloud, so to speak. And you can do that in Firebase as well. So you can basically set up functions that do interesting things. So I guess right now you thought, well, we only have some real-time database where we can upload data to, and we have some authentication where we can sign in, but we can't really execute interesting logic on the back end. But that's actually possible with these cloud functions, so to speak. And there's actually also a video, let's just watch that. I think they're better at explaining exactly what's going on than I am.
If you're an app developer, you know that a successful mobile app has lots of responsibilities. For example, apps built on Firebase use its authentication feature to sign in users, and they typically read and write data to its real-time database. They might also store files in the cloud using its scalable storage. These are all great features for building your app, but sometimes you can't put all your logic inside the app to run on the user's device. For example, prying eyes may try to reverse engineer and modify your app's code. Or maybe you need to change your app's behavior instantly, without publishing a new version that your users have to install. And sometimes it's best to have a single place where expensive work is performed. Traditionally, to solve these problems, you would deploy your private code to a backend server that you manage. The app would then use an API or library to communicate with that server and issue requests. However, with Cloud Functions for Firebase, you don't need to set up, maintain, and scale that backend to get its benefits. Instead, you can write and deploy code to our servers that automatically responds to events in your app. Did a user just log in for the first time? You can send them a welcome email with a function. Did that user insert a value into your real-time database? You can update it right away with a function. And did that user upload photos to your storage bucket? You can analyze, resize, and manipulate them all with a function. And finally, with a function, you can also send a message with Firebase Cloud Messaging to that user's friends so they can know what's happening right away. You can even create functions to build a web-based API for your data that anyone can use. You write your functions in JavaScript for the Node environment, and all it takes is one easy command line to deploy your functions for immediate use. With Cloud Functions, you can seamlessly integrate many features of Firebase to provide the backend services that your app requires to be fast, secure, and complete. And you can do it all without having to provision servers, tune them, upgrade them, and scale them up or down to meet your users' demand. We handle the maintenance and you write the code so you can quickly build apps without all the ops. To learn more about Cloud Functions and how you can use it to build out your Firebase app, check out the documentation right here. We can't wait to see what you build.
Great. Yes, you can see that is very powerful. It's basically just giving you your own Node.js backend to toy around with, where you can write functions and use them without having to set up the backend itself. So that's very smart. And then there is Google Analytics, which I guess some of you know already. Basically just helps us understand what the users are doing in our application and also how the application behaves. So you can basically analyze everything that goes on inside of the application. Whenever it crashes, you can send logs. You can see what kind of users enter into your application. You can see what activities they spend the most time in and these kind of things, and where they click. And there's a lot of analytics you can actually retrieve directly from your applications, and most of this is actually free, so you can just hook your applications up to analytics, and then you can get all of this data for free. So that's also very nice. And then there is Google Maps, and their platform, which basically allows you to put interactive maps inside of your Android applications, which might be very useful to your users in terms of like navigating, or maybe you have some kind of maps game where you have your own map integrated or whatnot. And you can even extract some of the data from the real world in terms of places where restaurants are located, or phone numbers and contact information for people and stuff like that. So that's also very powerful API. That's not part of Firebase right now. That's their own platform, you can say. So that's basically just a quick overview of some of the main features that Google offers. Now let's dive into the more specific ones in Firebase. So in order to use Firebase, the only thing you really have to do is to set it up using the console. So if you go to Firebase website here, then you can set up your own account and use it inside of your Android applications. But there's actually an easier way, and that is just to go inside of your Android Studio, and then go into Tools, and then Firebase here. And this is basically an assistant that helps you set up anything related to Firebase. So you can say, okay, I want to use the real-time database. And here actually there's a small guide that helps you save and retrieve data. And so if you're not connected to Firebase yet here, it would actually tell you here to connect. Now this application I'm in right now is already connected to Firebase. But it's basically just following these steps, and then you have a working application, like a minimal viable product for these kind of things here. So I would recommend you do that. But you can also do it through their website, where you can go into the console here and you can register yourself, and you can do it that way. There's a few additional steps, but it does the same thing in the end. Yes, and then remember, whenever you're using an emulator, some of these things require Google Play services. So notice whenever you're opening the emulator tab, that is actually one of the emulators you're using actually have Google Play services installed. Otherwise, it will not work. Okay. Now let's dive into how you actually authenticate the users in Android using Firebase. And let's just watch this small little video to get started on that.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of a user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, 3 things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Great. Okay, so that's basically what you can do with Firebase authentication. Now, there's actually some library built on top of the Firebase SDK called Firebase UI, and that makes these things even easier. What this does is basically gives you ready-made user interface, like you see here on the right, where you can determine what kind of sign-in providers you want to support in your application. So you can see in this one, for instance, you can sign in with Google, Facebook, Twitter, email, or even phone. Now this phone one I think costs a bit, but the others here, they're totally free. So the idea here is that by using Firebase UI, you can just tell the system what kind of providers to use. And as you heard in the video, it's possible to use this ready-made UI, but you can also provide your own user interface and then just tell the system what buttons actually specify to which of these actions here. And it also allows for anonymous user upgrading, so the user can enter the application without being signed in, and then at some later point they can actually just determine to sign in, and then their data will be saved in the cloud. And it also supports Smart Lock for Google, so that's basically where whenever you've signed in once, then you don't have to do it again, it just remembers that you actually signed in, so that's also very smart. And there's a getting started guide right here, but I'll just get you through it right here. So it is actually pretty straightforward 3-step process. You enable whatever sign-in providers you want in the Firebase console. I think I actually have that open maybe here. Yeah, so you go under authentication and then the sign-in methods here, and then you can see, for instance, for this application I'm using right now, I've allowed email and password, I've allowed Google sign-in, and I've allowed Facebook. So whenever you enable these, it will give you some additional steps. For instance, for the Facebook one, that it requires the Facebook SDK to actually work. So you have to use those dependencies as well in your applications. And then it's actually very simple, because the only thing you have to do in this case is to create your own sign-in intent. So you can see that's what's going on right here. We're creating a new intent, and as you already know from previous classes, when you are creating an intent, then you need to use that to start an activity, right? So you can see here we are starting an activity for result with this intent object. And this intent object here, that's basically, we're just using the builder pattern to build it up. And you can see we're basically telling it what providers to use. So in this case, that was the email, the Google, and the Facebook thing. So these providers here we are using in our intent. And then we're also just using a custom logo, right? That's what you're seeing right here. But you can actually also, in this builder pattern here, set up and tell the system, okay, I want to use my own user interface for this. It looks like this, and these are the buttons you have to use for this, this, and this. So that's also what you could do right here. And then the interesting stuff is that the only thing you have to do is use that intent in the start activity for result. And I guess you remember from previous classes that this start activity for result actually starts a new activity. And then whenever the user returns to this activity again, they would be greeted with a callback, you could say. So this on activity result method will be called automatically whenever you return to this activity. And in there you can handle the logic if everything went okay or not. Because you have the code right here, the request code they actually use to go to the second activity and go back again. But you can see this as well in an example where I've provided the entire code. So you can see right now, this is only part of it. You would have the callback, the on activity result callback, where you actually handle if everything went okay or not, and then let the user into the main content. And then of course it should also, you're going to somehow manage the users, right? So whenever they enter the main activity, it might be a nice place to check if they're actually signed in or not, right? So you can see right here, we're basically accessing the user by getting this instance of the Firebase authentication, and then we can get the current user. So there might not be a current user. In that case, you can just start in a logging activity. But if there actually is a current user, then you can do whatever you want. Like you could display, as I'm doing here at Toast, where you're just having a greeting to the user to say, hey, welcome, whoever you are, and then the name is actually already inside of Firebase. If they sign in with Google at least, then you have a display name as well. So that's pretty straightforward. It's just you can access the user from this authentication instance, and then you can check if they're signed in or not yet. And you can also sign out very easily just by using this sign out method on the auth UI instance right here. And the cool thing about that is that it works right out of the box with stuff like Smart Lock and all of the third-party identity providers. So that means it will automatically sign you out of Facebook if you've used that to sign in, and it would not remember anything of the Smart Lock functionality afterwards. So you basically just have this listener here with a callback, and this onCompete callback here will be called whenever it's signed out. And in this case, I just referred them back to the login activity because they signed out, they have to sign in again, right? You could of course also have other functionality. You could have an application where you're actually allowed to go into the to the main content, so you would not be redirected to any login activity, but it's just like a more simple version, right? And then whenever you log in, you might be redirected or use another user interface for that. The same goes for if you have some kind of administrator functionality or whatever, then you can display some other user interface to that administrator depending on what the title or status they have. And there's some more information about how you can manage users down here and other things you could do with them. Okay, now let's look at how you can actually store data in the cloud. So now we know how we can actually sign in, but it's not really interesting to sign in unless you can actually have your own data stored somewhere. Right, so that's what we're going to look at now. And let's just watch this small video.
When you're building an app that needs to store and share data from a server, there are a lot of things that you'll need to keep in mind. Setting up and maintaining a database can be a hassle. And if you want your data synchronized in real time or need offline support, well, now you're talking some serious time commitment. But with the Firebase Real-Time Database, you can get that time back. The Firebase Real-Time Database lets you store and sync data between your users in real time. This makes it easy for your users to access their data from any device, web or mobile, and it helps your users collaborate with one another. Whenever you update data in the real-time database, it stores the data in the cloud and simultaneously notifies all interested devices in milliseconds. The real-time database is also optimized for offline use. Whenever a user loses their connection, the database SDK uses a local cache on the device to serve and store changes. This means that when the user comes back online, their local data is automatically synchronized. And how do you keep your data secure? You can use database security rules to specify who has access to what pieces of data and how your database should be structured. The security rules are securely stored with the real-time database on our servers. So if you want to make sure your users can only access their own data or ensure that their message is no more than 141 characters, you can do that in just a few lines of code. Getting started only takes a few minutes. The Firebase Real-Time Database is hosted for you in the cloud, so there's no server maintenance or operations. And there are SDKs for Android, iOS, and JavaScript. To get started with the real-time database, check out our Quick Start, which will get you up and running in minutes. We can't wait to see what you'll build with Firebase.
Yes, so that's basically the real-time database part. There's actually two options you can choose from. So basically the one we're going to look at today is the real-time database, but I also have a new document-based solution called Cloud Firestore. You can learn about the differences here by looking through that, but basically they are also very similar in the terms of they're both NoSQL, they both have a very similar API, and yeah, it's basically just there are some more scalable features here in the Cloud Firestore. It can support more users, but this real-time database is also fine if you just structure the data correctly. And talking about that data in this NoSQL database, it is actually just a cloud-hosted JSON tree, you could say. So that means you basically have your data as one large document, one large JSON document. And in that, of course, you have a lot of nodes, right, with some children. So in this case, this is the node where you can say the key is messages, and all of the messages is of course message 1, message 2, message 3, and then message 1 also, you could say that's a key or a node that has a name and a text, right? So that's basically just how it's built up, and since it is a NoSQL database like this here, document driven and these kind of things, then there are some best practices which you should follow, which are quite different from having a relational database. Like you should focus on denormalizing the database and having a very flat structure, so that whenever you fit some of the data, you don't get the entire JSON tree at once. But basically just read through this and see how to structure the database. They have some good guidelines. Good. In order to use this real-time database, first you have to set up Firebase, as you saw in the previous slides. And then after that, you can basically get a Firebase database reference. And this thing right here, whenever you get the instance, you have to specify where in the JSON tree you want to get access to. So if you leave this empty, you'll just get root access. So that's basically the start of the JSON tree. So you can see there's some data right here. So that's basically up here, right? And then you can use the child method whenever you have a reference to somewhere in the database. For instance, the root right here. You can say .child, and then in this case it's the child node that's called Pokemon. So that's this one right here, right? And then you can set the value for that. So if you want to save some data, you can say set value, and then in this case it's just a Pokemon object it's saving. And that's basically with these two values right here. So you can see there's a name and there is a number. So Pikachu is the number 25th Pokemon. So this is all good and all. You can just use the you have a reference to somewhere in the database, somewhere in the JSON tree. You specify what node to actually save. So in this case it's the Pokemon here, and then you can basically set a value to that node. And in this case it's just a Pokemon object of two values. What you can also do though is you can use what is called a push ID, and that is when you have the reference, instead of specifying a concrete node here to put it into, like we're doing here, then you're just writing push, and then you're setting the value, and that gives this weird thing up here, and that's basically what's called a push ID. And this can be very smart if you're, for instance, creating a chat application. So if you want to have some kind of interactive application where you have multiple users involved and they're sending messages at the same time, and you want to make sure that these are ordered in the correct manner, so that the first messages that are sent in time comes first, and then the new messages comes afterwards. Then it can be very tricky to figure out if multiple users are sending messages at the same time, which one comes first. So that's basically what this push ID here is solving. So basically these things right here, these bits, some of them are just random to make sure that it's a unique ID, and others are basically part of a timestamp. So Firebase knows which messages to display first and which messages to display later. So that's very smart, and there's a small little blog post here of how exactly they're generated. But if you want something that involves multiple users and you want something to be shown in a chronological manner, then use push IDs instead of specifying exactly what kind of child you want to actually be posting the data to. Okay. Whenever you want to deserialize the JSON into Java objects, or the other way around, then Firebase actually can do most of this for you in exactly the same manner as we saw last time, where we used retrofit with JSON. Then basically you just have to supply your plain old Java objects with the same fields here, the same field names as in your child keys here. You can also have some annotations here if you want to change the name, but other than that it's the same as last week. One note though, you would have to have this default constructor, this empty default constructor, for this to work. And then when you have these objects here, then it's, if you want to send some data, if you want to serialize some data, then what you do is basically just, you can see you have a reference here, as on the last slide, with some node. In this case it's the users node, and we're supplying a specific node called something with the user ID, and then we can set the value to that user object. And then it just works, like it knows how to put these things here into the JSON format. And when you want to go the other way, it's actually also very simple. You just have to specify what class you're actually going to retrieve. So if you have some JSON data, then you tell it, okay, this JSON data should actually be of this format here, and then it converts it automatically. Whenever you want to retrieve data, you have quite a few options. So you can see here it's still just a reference, so somewhere in the database you have access to, and then you can call some various listeners on that reference. So you basically have two options. You have the value event listener, that's what we're using right here, and then you have the child event listener, that's what you're seeing right here. So both of them is basically just adding a listener, and then you have this anonymous inner class here of this interface that has a callback. So you can see whenever data is changed, then this method here would be called. Now this value event listener, that's called once whenever you start up your application, and then every time data changes for this reference right here. And whenever that changes, it's the entire reference you get back. So that means you will get a lot of data whenever this fires here. You get the entire reference, so all of the child nodes as well. If that's too much for you, if you don't want all of that data, then you can just use this method instead. So that would only send back the actual children that was modified by using add child event listener, and then you can see on child added, then you would get the exact child that was added, and on child removed, then you would get the exact child children that was removed. So depending on what you want to do, if you just want to fetch all of the data from the database and you only want to do it once, then you can just use this right here called add listener for single value event instead of this add value event listener. And then it does the same thing, it just gives you the entire JSON tree that you can then parse or do whatever with you want. Okay, and notice that these are listeners, right? So they're going to listen all the time for changes in the database. So what you want to do is you want to make sure whenever your application is working in the background and you're not really using it, you don't want to listen for stuff. So make sure that you use the various event functions, lifecycle methods to actually detach and attach the listeners again. So for instance, in onStart and onStop, or in onPause and onResume. Okay. And yeah, you can see right here, I basically just, this doesn't do anything, right? It's just, I'm getting the snapshot, so that's all of the data, where I'm getting the value from it, and that's basically a Pokemon object, right? That's what I'm specifying right here, but I'm not doing anything with it. So most of the time here, what you would do is either setting the data on some text view or whatnot, or you might notify your observers using live data, right? So you might notify any activity about any changes that happen to the database by using live data here and then set value. Okay. As you heard in the video also, Firebase is not only used for authentication, but also for authorization. So that means your server, it's not only about your backend here, it's not only about who you are, but also what you can do. So you can basically set up rules. So if I go into the Firebase thing right here, and I go into my database, then I can go into the rules right here, and then I can tell right now it's just everyone is allowed to read and write. That's actually not good practice. You should never do this in production. You should have some kind of authentication required at least. But the interesting part here is you can say who are allowed to do what, and you can also say what kind of data is allowed into your database. So you have some kind of validation of the data that goes into your database. So that's very powerful if you have some application that has some kind of administrator or whatnot, so you can separate between normal users and administrators, and then you can say here what kind of data in the database they have read access to and what kind of data they have write access to and stuff like that. And you can also play around with it with this button up here, where you can be taken to a place where you can just do things without it really affecting your database. Okay. And that's pretty much it. So let me just show you here. I have an example here I just made very briefly that has a sign-in. So you can basically sign in. And now this is smart log, so it tells me, do you want to sign in with this email account you already have here, or do you want to do none of the above and then go into some format where you can specify Facebook login or whatnot. But I'm just going to sign in with my Google account here. And then I'm taking directly, you can see welcome Kasper Knob Rasmussen, and then there's a name of some Pokemon right here, and I can put in another Pikachu and then press save, and you can see then it's displayed here. But it's not just as simple as this data is fetched right here. This data goes all the way to the Firebase backend, and then it's displayed here again. So I can actually show you here on the backend. I have the data here. You can see it says Pikachu right now. So if I open this up and then write something else, let's see, Bulbasaur. So you can see, look here, this data here, the name of the Pokemon, that's actually what I'm changing. So you can see it's changed instantly also right here. So this is basically our JSON tree right in the Firebase database backend, and we can change that directly, and then all clients are updated within milliseconds. So that's very, very powerful. I have this example here on GitHub, so you can go through it and see how I set up the login process and how I set up the Firebase real-time database. It does not use any architecture components, so it's basically just a simplified version of that. If you want to use any of the architecture components, I actually suggest you read through this blog post. It is a bit more advanced, but it helps you set up the live data in a very convenient manner. So that's very powerful if you want to use Firebase together with the architecture components. And then some of you might also want to display some data from Firebase in a list, so using recycler views. And for that you can actually also use Firebase UI, which makes it a lot easier to do these kind of things. And there's a link to that as well right here. But that's basically it for today. Like, you're going to focus on the authentication, and then you're going to focus on the real-time database. And I've made these small exercises here where you can see it's going to take 1.5 hours approximately, where you're going to go through how to set up Firebase, how to use authentication, and how to work with the real-time database as well. And then if you have the time for it, I will suggest that you look through some of the blog posts and things I've linked in the slides as well. Okay, that's pretty much it. Bye everyone.